Thank you very much. Good afternoon. It's always difficult to be in the last session, but I'll try to be entertaining. The main area of this session is technology, but before I start, I just would like to put up a few quick statistics, obviously about PBS vehicles, which I think would be interesting for the audience here. In terms of the fleet, you can see on the chart that we passed 12,000 PBS combinations in the last month, which is a big number because originally in the RIS, which was done in 2011, 2012, they predicted that we're going to have 12,000 combinations by 2030. So we reached that level basically 9 years before. On the side, you can see that in terms of the PBS levels, that mainly level 1 and level 2 combinations are representing the majority of the fleet. And on the bottom slide, you can see the PBS combinations per year. You can see that 2020, there was a very, very slight drop in terms of the combination numbers, but it's still a reasonably large number. And this year, in the first 4 months, we put more than 640 combinations on the road. So hopefully this year is going to be a good year for PBS. In terms of the tankers, they are representing roughly 5% of the PBS fleet. So it's a relatively small segment. The middle of that chart, you can see the different classification in terms of tankers, and you can see that dangerous goods tankers around 34% and around 60%, which are the non-dangerous goods tankers. So these are the milk and water and others. The chart also shows the different combination types, and what's a surprise that in terms of tanker vehicles, you can see that A-doubles are the most popular combinations at this point in time, which is a trend, what we can see. I think we've seen this in the last few years, that both the 26-meter options and the 30-meter larger combinations are very, very popular or popular for this segment of the industry. I asked Adam if he presented any safety data about PBS vehicles, and this report hasn't been released yet, but it was a CILTA NTI study. As part of the PBS tire review, we compared the safety performance of the prescriptive field versus the PBS field. And you can see that in terms of the conventional vehicles, there is a significant improvement in terms of the safety performance of those vehicles. If we look at the distance traveled basis, and this is a very, very significant study because it covered 5 years of crash data from NTI and also a research, an operator research, and a large number of PBS vehicles. PBS combinations, the number of PBS combinations has grown significantly in the last 5 years. And in terms of all the different safety measures, PBS vehicles are performing extremely well. So I guess that's a message for this industry segment that these vehicles are safer than the prescriptive ones. In terms of regulations, and I don't want to talk too much about that, obviously we've got some safety technologies which are mandated in the different ADRs. The anti-lock braking system, stability controls, and for front underarm protection. Obviously, the NHVR is not controlling that process, but we are contributing to the ADR developments. what we are controlling, that we are trying to encourage industry to use some of these technologies, and I think in some of these presentations there will be examples of that. And last year we put together this setup program where we are trying to use other market tools to encourage the take-up of technologies. I guess using technologies during the access approval process is one element, but also looking at some of the regulatory tools like different guidelines for managing the operation of these vehicles. That's another option where we could use technologies. What I would like to show you this afternoon, a few examples, and I'm not concentrating on safety technologies because the other speakers will be concentrating on that. I will be showing a few examples of technologies what we use for improving vehicle performance. And some of these technologies are around and accessible for the industry, but sometimes the regulatory framework cannot handle those. So the first example, what I would like to show you, it's basically a system where we had the PBS vehicle, and in order to comply with the PBS requirements, it required some technologies. And this one is from Knorr, looking at steerable axles, so a steering system which is applied for this one. This is a 42-meter long B-triple combination developed under the PBS scheme, and the interesting thing was that in order to comply with the PBS sweat part requirements, the application of some sort of steering technology was required. This vehicle has steerable axles on all of the trailer groups. One group has two, and the other two groups have one axle as well. What's the interesting thing is that these are programmed because obviously while self-steered axles are very beneficial in the low-speed turning maneuver, those axles can be more dangerous during high-speed operations. So thanks to technology, these steps unit can be programmed that they only apply the steering when the vehicle is traveling in a reasonably slow speed. What was interesting that after the initial operation, the operator experienced some problems that they couldn't really reverse these units properly because the axles weren't locking properly, so they had to modify the operation of the system. And I'm not sure, can we run that simulation again, please? If you just click on them. On the left-hand side, you can see this B-triple turning with no steer axles. And on the right-hand side, when the steering system is activated, and you can see that roughly the improvement is more than a meter in terms of the low-speed sweat part performance. Another example, looking at application of the technology, and this is the I-corner system, which has been tested recently, and also again this is a PBS application. What you see up there, what's happening that during the turn, load is transferred within the axle group. So the air pressure in the last axle of the trailer group is dropped, and therefore more load is transferred to the first two axles of the group. And that means that the theoretical wheelbase of that trailer is shortened. So that means that it improves the low-speed turning performance of that. If we can run that again, so you can see those simulations there, one with the steer axles and one without it, and you can see that the vehicles can meet the PBS requirements if that technology is applied. Now the problem is that what happens during that turn, that trailer axle group is not load sharing. So it's against the current ADR requirements, which require that you have to have a load sharing suspension system vehicle fitted to trailers. So in this case, the regulations basically don't provide you the framework to use these innovative technologies and maximize the productivity of these combinations, because what it means that longer trailers would be able to meet the PBS requirements, and the longer trailers can deliver significant benefits to the operators and also to the economy. The next issue is tires, and this example is about a PBS A-double which has been approved with super singles, and I'm pretty sure you've seen some debate about the super singles because the current regulatory framework is really not supporting the application of super singles, despite of the fact that super singles can deliver significant benefits in terms of improved stability and also reduced roll resistance and reduced fuel consumption and so on. But under the current MDL, the mass dimensional loading requirements, there is a mass penalty if you use super singles on your combinations. So in this case, we approved the operation of this vehicle under PBS. And in terms of making it sure that the tires are operating at their optimum sort of performance level, this combination is with the tire pressure monitoring system. And I've seen Chad around and a few guys here who are very interested in delivering these systems. So in this example, I think the important thing is to review the existing regulations and making it sure that existing regulations are keeping up with the development of the industry. Just finally, we've got a number of innovative designs. Again, in my thinking, this is all technology, and you've seen the introduction of multiple axle groups on semi-trailers. Again, industry is looking for increased productivity, and putting more axles under some of these vehicles can deliver that. Obviously, again, the regulatory framework cannot really handle that because these vehicles are not compliant with the current definitions of semi-trailers. But we've seen a number of these vehicles with different axle configurations. In terms of the technology, what we need, and that I think this is a good example, a very nice looking unit here, which is again approved under PBS, but it's operating in WA. The increased number of axles again can lead to productivity improvements, but in terms of the technology, sometimes the technology is not keeping up with that, because most of these technologies are developed overseas, so mainly in Europe. So for instance, if you look at that second semi-trailer, and you've got 3 axles on the dolly and a quad on the semi, managing braking systems and managing compliance with some of the requirements is a challenge for the suppliers of these technologies. And the last issue is that also evaluation of the technology. So for instance, self-steered axles. We looked at the performance of these self-steered axles under certain conditions. Obviously, self-steered axles can help with improving low-speed performance, but if they are not locking properly, if they are not performing well under high-speed conditions, they can lead to instability, and that could be a problem. So from the regulatory perspective, we need to have these tools to assess these technologies which applied for these vehicles. And I think that was my last slide, so I kept my time. Thank you very much.